So here is our ventilation system for Rochester Passive House. Okay, ventilation is an extremely important part of the whole passive house, the passive house movement. We want to be able to provide fresh air 24/7 to its occupants, but we don't want to overventilate. We want to optimally ventilate. This unit, while it is extremely energy efficient, it isn't 100% efficient. Okay, so when we overventilate something, we're creating unnecessary energy losses. Okay, we're also running the risk of overventilating and creating drier air and creating some other issues. So we want to optimally ventilate. Generally speaking, for a single family house, we want to target about one full air change of air in the house every 3 hours. Okay, so using that is our design guidance. We then take a look at the floor plans. We want to make sure that we are supplying fresh air to the bedrooms and the living spaces. And then we are going to send that fresh air through transfer zones, usually hallways. And then that fresh air is going to go out the bathrooms, the laundry room, and the kitchen. That's going to provide a nice cascade ventilation effect. Once we've figured out the design and how much air needs to come in and go out, and where it's coming in and where it's going out, then we need to lay out the machine. And we've got fresh air pipe that's actually coming down this chase here, and it's going to come into the machine. Now this first box is an optional add-on. Okay, this is a true geothermal loop. Okay, all we've got, and if you took the cover off here, you would see this picture. So we've got fresh air that's coming in down here. Okay, so here's the filter slot, here's the filter slot. So fresh air is coming in down here. It's going to be going through this filter, and then it's going to be going through this, what looks like a car radiator. Okay, so the way that this is going to work is there's a small pump, and this pump is pumping a glycol solution through this hose around the footer of the house and back to the unit. Okay, so this tube going through the radiator here is ground temperature glycol. We're going to be taking 5-degree air, we're going to filter it, and then we're going to preheat it using the ground temperature. Okay, so 5-degree air over here is going to become 30-degree air over here. Okay, so this is just tempering the incoming air. This air is then going to be going through the pipe here into this box. So over here is the air-to-air heat exchanger. So we've got another set of filters, okay, another set of filters here, and we're going to have that fresh air coming in, getting filtered again, and then that fresh air is going to go through this air-to-air heat exchanger. So while we're bringing fresh air in all of the time, we are also at the same time taking stale air out of the kitchens and the bathrooms. That air is going to be coming down the pipes here. It's going to be filtered, and then it is going to go outside. So in here we are going to recover about 85 to 90% of the heat from the outgoing air and putting it into the fresh air, so that when we're distributing the fresh air to all of the living spaces, it's no lower than 62 degrees.